Am I audible?
Yes, sir, you are audible.
So, good evening,
Hi,
all.
good evening, Ashish ji.
Good evening, Deepak.
Good evening. Dr. Meherchand, it's 6 o'clock. Should we start?
Yes, ma'am, we should now start.
Okay.
Thank you, Dr. Meherchand, for inviting us, and it's my pleasure to welcome you all. Very warm good evening from India. Would like to introduce first of all Dr. Sudhir Rajiv. She is our Dean International. Myself, Dr. Ashish Manocha. I am Head of Department of School of Public Health at Poornima University. Welcome you all. It's a great pleasure to see every student at the same platform from different countries. I think 14 countries students have joined this international conference on research methods in public.
Ashish sir, the Ethiopian counterpart has to first give an address, then I'll, and then you will.
Yeah.
Yes, Dr. Meherchand. Sir,
Yes, ma'am.
who's starting? Before me, someone has to speak.
First, there will be welcome address.
Okay. So
Yeah, ma'am.
it's my turn?
Yes, ma'am.
Yes.
Okay. A very good evening, ladies and gentlemen. A warm welcome to everyone who has joined from the various parts of the world. It's my pleasure. It's a great day for all of us that we are meeting for an international conference, a 5-day international virtual workshop on research methods in public health, organized by the College of Health Sciences, Mizan Tapi University, Ethiopia, in collaboration with Poornima University, Jaipur, and MathStack Thinking Foundation, India. First of all, I would like to welcome each of you, the participants, who have made our efforts worth our while by joining us. The topic is quite relevant, not only to the university, not only to the academic world, but we have gathered here in the cause of humanity. After having faced the pandemic, I think it's the ongoing thing, we have gathered here to reinvigorate ourselves and to see what we as health workers can contribute to the community where we are needed the most at this time. We need to explain how people experience a particular health issue, taking into account the specific social, political, economic contexts. In short, what is important now is community public health. We are so excited to have 257 people from 13 countries. I'm glad to say that scholars from all over the world have shown enthusiasm and have acceded to our request. Over these 5 days, we will have many sessions on data collection, epistemological study designs, clinical trials, research ethics, systematic reviews and meta-analysis, and what have you. So you have your plate full. Please fasten your seat belts as we take you on a journey to more learning, a journey where we interact, a journey where we will learn from each other, share our experiences. It is my distinct honor to accord a special welcome to the Chief Patron, Dr. Abiyat Assaris, Assistant Professor of Public Health, Vice President Research and Community Services, Mizan Tapi University, Ethiopia, and the patron, Mr. Andula Henok, Chief Academic and Research Director, Mizan Tapi University, Ethiopia. I'm so excited to have such eminent and erudite keynote speakers like Dr. Dipanjan Roy, Dr. Kander Mathur, Dr. Harmanpreet Singh Kapoor, Dr. Geeta Ravindran Menon, Dr. Abiyat Assaris, and of course, a very, very warm welcome to my comrade in arms, Dr. Ashish Manocha, who is the head of School of Public Health from Poornima University, Dr. Bharti Kapoor from Punjab, Dr. Wunwosan Nigusen from Mizan Tepe University, Ethiopia, and our very dear friend, Dr. Meher Chand, who has actually organized everything, helped us every step of the way, and taken us ahead. And we have seen the fruition of all that all of us have put together today in the opening of this session. I welcome each one of you for your commitment to health of people at large, for your commitment to issues of health. We are so excited that here we will start our experiences, our learning, share, interact. I do hope that our deliberations over the 5 days inspire us to make our academic work better and help us achieve greater insights into the need of the time, and that is community public health, and thereby help us to provide solace to the sick, to the needy, to those people who need us, to whose side we can take hope and pleasure. On that note of hope, I welcome each one of you who's present here. A special welcome to my colleagues from Poornima University, Dr. Ashish Manocha, Dr. Kandarp, Dr. Dipanjan Roy, my colleague, Dr. Meher Chand, and his friends from MMF, and the galaxy of people from Mizan Chapi University. Together, we will do it. Together, we will make this also a very qualitatively rich workshop. Thank you for joining and welcome once again to this 5 days workshop on research methods in public health. Before I leave, I would like to thank Mizan Tepe University and Dr. Meher Chand and his institute, Math Tech Thinking Foundation, for collaborating with us, for inviting us, and for holding the reins together. Thank you once again, and welcome, welcome, welcome. Thank you. Have a great workshop. Wish you many, many happy deliberations and learnings from this workshop. Thank you. Dr. Meher Chand, it is now over to the speaker.
Now it is turn to invite for opening speech from Mizan Tepe University.
Okay. So I invite for the opening ceremony, I now invite our counterpart from Mizan Tepe University, Ethiopia. May I request for Mr. Angulum Henok for the opening address. Mr. Angulum Henok, if he is there, would request him for the opening address. Dr. Meher Chand, has he joined?
Just 1 minute, ma'am.
And sir, you need to unmute the speaker, Dr. Kander Mathur and Dr. Ashish Manocha, who would be chairing the session. You need to unmute the two of them, sir.
Yes, now they can unmute themselves.
Okay. Okay. Kandarp, sir, are you able to unmute yourself?
Yes, ma'am. Am I audible?
Okay.
Very warm
Okay,
good
yes.
evening to everyone.
Good evening. I would like to introduce Dr. Kander Mathur. He is our speaker for today's session. He will be talking about the data collection methods, or you can say different methodology of data collection or data survey.
You're not audible. You're not audible.
You are not audible, Ashish.
Am I audible now?
Yeah,
Yes.
just increase the volume of your this thing. Dr. Meher Chand, is Mr. Angela Henok not there?
Just 1 minute, ma'am.
In the meanwhile, Ashish sir, please raise the volume, increase the volume of your this thing.
Ashish, please speak again.
Ashish sir? Ashish sir?
Now am I audible?
No, you have to raise the voice, Ashish.
Just a second.
Yeah.
I can hear you. I can hear you.
Yeah, now am I audible?
Yes, you are.
Yes. Yes.
Dr. Milton, do we wait for Mr. Hino?
We should start. I think he is not able to join us. We should
Okay.
start.
Okay, so Ashish sir, it's over to you for Dr. Kander Mathur's. He is the resource person for the next session, and my colleague Dr. Ashish Manocha is going to chair. Over to you, Dr. Ashish Manocha.
Yeah, thank you so much, ma'am. And I would like to introduce Dr. Kandarp Mathur, who is a resource person or speaker for today's session on data collection methods. And Dr. Kandarp Mathur has a background of dentistry. By technical education, he is a dentist. He pursued MPH from Jodhpur School of Public Health. He is also PGDHM, and currently he is pursuing PhD in Public Health from Poornima University. And he is a deputy head at Jodhpur School of Public Health at Maulana Azad as well as Poornima University. So I would like to invite Dr. Kandarp Mathur. So over to you, Dr. Kandarp.
Thank you, Ashish. I hope I'm clearly audible. If not, kindly please
Yes,
ask
you're
me to
audible.
do so.
No, you
Okay.
are audible.
Okay, ma'am. So, a warm welcome to everyone. And I will not take much time because the formalities have been done. So, I'll straight away start with my presentation. Please feel free to ask me to, lower my pitch or, reduce my speed of presentation so that it's, easily understandable to everyone. So, I'll start with the presentation. Please do inform if the screen is visible.
Yes, sir, it's
Yeah,
fine.
it's visible. It's
Okay.
visible.
So today we'll be talking about data collection and methods. And my name is Dr. Kander Mathur, as Ashish introduced. And I'll skip my introduction for now because it has already been done. So we'll straight away start with the first topic. What is data? So whenever we hear the word data, what comes to our mind? So data is any factual information used as a basis for reasoning, discussion, or calculation, right? So any factual information which can be used for reasoning purposes, for discussion purposes, as well as for calculating something is called as data. Now, data can be measured, it can be collected, it can be reported, it can be analyzed, whereupon it can be visualized using certain graphs, certain images, or other analysis tools. Right? You must have seen all the wonderful graphs and charts given by the WHO or given by any other major UN organization. That is not possible without data. Now, basically, there are two types of data. The first one is the measurement data, and the second one is the categorical data. Measurement data is also called as quantitative data, and categorical data is also called as qualitative data. Right? Then we further have a subdivision. Measurement data is of two types, discrete and continuous, whereas the categorical data is of two types, nominal and ordinal. Now, first we talk about measurement data. Now, in measurement data, the objects we are studying or the objects being studied are measured based on some numerical trait. There is some number associated with the data, and that is why we call it measurement data, or it is also called as quantitative data. Now, it is further of two types, discrete and continuous data. Now, discrete measurement data, only certain values are possible. Generally, we say that discrete data are counts. So whenever you count something, that is discrete data. The examples include number of head injuries in road accidents. So the count of number of head injuries in road accidents in a year for a given particular area, that is an example of discrete measurement data. The other example is number of times cardiac operations are performed in a day. So any count comes under discrete data. When we talk about continuous measurement data, theoretically, any value within an interval is possible. So an interval is a range basically. So any value within a range is possible with a fine enough measuring device. Now generally continuous data comes from measurements. Okay, and what measurements? The examples are your cholesterol level, your height, your age, the time to complete a postmortem. All these examples, all these measurements have a range to them. And that is why we call them continuous measurement data. Next, we talk about the categorical data. Now, the objects being studied are grouped into categories which have some qualitative trait. Now, just like in quantitative data, we were concerned with something numerical. Here, we are concerned with something quality based, right? Or in other words, we can say it is also called as qualitative data. Now, the resulting data are merely labels or categories. So anything with a label attached to it, a label associated to it, and a category associated with it comes under categorical data. Now, categorical data are commonly summarized using percentages. So whenever we talk about something, whenever we cite an example, let's say, 40% of the people in a particular area are suffering from malnutrition. That 40% basically is categorical data. There are two categories now: people suffering from malnutrition, people not suffering from malnutrition. So now there are two labels associated with such data, and therefore to convert it into numerical data, we express categorical data in percentages. You can see your examples in front of you. 11% of students in a school have dental cavities. 33% of coronary heart disease and 26% of lung cancer deaths were the leading causes from the study on causes of death. So all these percentages, they are actually representatives of categorical data. Now, just like measurement data was of two types, categorical data is also of two types: nominal and ordinal. The first we'll talk about nominal. This is the type of categorical data in which objects fall into unordered categories. There is no order to them. They are simply tags. They are simply labels associated with it. So nominal data have no order, excuse me, and thus only gives names or labels to various categories. The examples include your hair color. Now, some people's hair color might be brown. Some people's hair color might be red. Usually we have the black hair color. Some have blonde hair color. So all these are simply categories. So out of a class of 50, how many have brown hair? How many have black hair? We can segregate the class basis on the basis of that, right? So such sort of data where there is a label, there is a category, but no order is nominal data. The other examples include race, the Asian race, the African American race, right? So all these races. Then the smoking status of a person, whether the person is a smoker or a non-smoker. This also is nominal categorical data. We are having categories, right? And those categories have certain names associated with them or labels associated with them. So a person can either be a smoker or a non-smoker. So those two categories are there, and such sort of data is called as nominal data. On the other hand, when we talk about ordinal data, here order is important. Now, what happens is sometimes the categories can be ordered. Example, a diseased person can get better, or he can stay the same, or he or she can get worse. So there is no obvious weighing system. Often these are scored as 1, 2, or 3. So you must have come across, surveys with questions like, how will you express your pain? Or, you go to a doctor when you are in pain and you ask the doctor, I am in pain. So the doctor simply asks you, how would you describe your pain on a scale of 1 to 10? You say, okay, I'm having a lot of pain. So let's say 7. So what you are doing is there is an order with that. So another example can be degree of illness. Your illness can be none. You have no illness. You can have mild illness. You can have moderate illness, or the degree of illness can be severe. So this none, mild, moderate, and severe, this sort of data is called as ordinal data, right? There are categories, but those categories are arranged in an order. I hope I'm audible and understandable. If not, kindly interrupt me and ask me to slow down a bit. Is it okay with everyone?
Okay.
Yes. Yes.
Okay. So I'll proceed with that note. So now, why do we care about the type of data we collect? Now we have talked about the data, the types of data. Why do we care? The simple reason is the type of the data collected in a study determines the type of the statistical analysis which will be used. Whether we run a parametric test or a non-parametric test, which are certain types of statistical procedures, will solely depend on what sort of data we have collected. So these are certain examples of statistical analysis. I'm sure other people who will be after me in this workshop will definitely talk about these methods. So you have regression, you have logistic regression, you have survival analysis, you have all those parametric tests, you have chi-square test. So all these types of statistical analysis are only possible if the type of data is known, whether it is measurement data or categorical data. Now, next we move to the clarity of questions for collecting data. So now we know what type of data exists. Next, we move to the questions. What sort of questions, or how do we, one of the primary ways in which data can be collected is through asking questions. I'm sure a lot of, you who are the attendees, who are the participants, have asked questions for a survey or for, your personal life or anything. So one of the primary ways in which data can be collected is through asking questions. So, these are dear friends, what, when, who, why, where. All these W's are our good friends. Therefore, it becomes very important to ask the right questions. Yeah, somebody was trying to speak. Anyways, therefore, it becomes very important to ask the right questions to get the right answers. Now, if you don't know how to ask the right questions, you don't expect right answers from the people, right? Who you are asking the questions to. So it becomes very, very important to ask the right questions. Somebody was trying to say something. Somebody has a question.
Any queries?
I think I'll let it pass. Probably someone's microphone is on. Anyways, so how to make sure that we are asking the right question? So we have already established that it is important to ask the right question, but how do we make sure that we are asking the right question? Now, the first thing which we do is make sure that the personnel associated with the data collection procedure are well informed of the objectives. That's very, very important, right? The person who is collecting the data must be well informed of the objectives of the study, or must be well informed on why you are doing this particular research or study. What this will do is this will help in eliminating potential misunderstandings and errors that could possibly lead to a biased result. I would request.
Dr. Meherchand, I would request to please mute SI Belay.
Asai Bile, I request you please mute yourself. Your mic is unmute. Asai Bile, please mute.
Moving on. What this will do is once the personnel associated with the study know the objectives, this will help in eliminating potential misunderstandings and errors that could possibly lead to a biased result. Now, we have to be sure that the good questions are specific to the problem under the study. Now, the better the question is, the more useful the data will be. And it is the same for both qualitative as well as quantitative studies. Okay. Now, very importantly, stratifying factors such as demographics, grouping of relevant questions, how you group your questions, how you place the demographics, what sort of questions you ask in the demographics section, the groupings, the various types of questions which you group under one category, how you do that are very, very important to the problem under the study. So we have to make sure that the data collection plan and the form, the survey form or the questionnaire we are talking about, considers them. It's very, very important. If our form is incomplete, if we don't ask the right questions, we don't expect right answers, this will make the data collection effort easier and will definitely save time. So these are the first two things which you want to do when you want to ask the right questions. The third point is actually very simple. We simply use the KISS principle. The KISS stands for keep it simple, stupid. The more simple you keep it when you design the form, the better chances of getting a clearer answer, or better chances of getting the more accurate answer, the answer which you are looking for. More complex the questions are, higher the chances of errors are present. Okay, so we always use the KISS principle: keep it simple and stupid. Okay, try it out. Very important. We should always try what we are going to publish, or if we are going to administer a survey questionnaire or a survey form in the general public, it is very, very important that we try it out first. And how do we try it out? We try it out through pre-testing and piloting of forms. So pre-testing and piloting of forms and questions is very important. What this does is this helps us in realizing the refinement required in the questions to provide the data we are looking for. It's very, very important. Now, you can't possibly know that your questions are right without pre-testing or piloting it. Once you go to the pre-testing phase, you understand that, okay, there are certain mistakes with the questions in the form which could have been avoided. So simply to make sure that the questions are right, first you try out your questionnaire or survey form before administering it to the intended target population. Now, forms and data collection instructions should be modified as appropriate based on the trial. It's very, very important. Based on the results of the pre-testing or the pilot study, there should be refinements or modifications in the questionnaire as they seem appropriate. Okay. Now, while we talk about pre-testing and piloting, let's talk about it a bit more. Now, the first thing is pre-testing the forms or the questionnaire. You can call it a form or a questionnaire. It's up to you. Now, it's important to test the form before using it to collect data. It's very, very important. Before administering it to the general public or the intended target population, it's important to pre-test it or test it before. Now, what pre-testing does is it helps us in identifying the questions which need refinement or help us detect any problem with the form which might lead to a bias. Now, you have asked a very good question, but there is a grammatical issue with it. That question needs refinement, because what will happen is you would try to ask something and the user or the respondent will perceive it as something else. The user will think that it is something else and will answer accordingly, and you might not have the right answer, or you might have bias, in other words. So what pre-testing does is it helps us in identifying the questions which need refinement. Okay, often, and it happens in major study, it happens a lot, pre-testing is neglected as it is considered to be time consuming. So many big studies or many studies where time is a constraint, what people do is people thoroughly neglect the pre-testing phase, and what that does is this is a mistake, because that brings bias into the equation, and whenever there is bias into the equation, the accuracy of the results will suffer. So even minimal pre-testing can help us reorienting our questionnaire. And by minimal pre-testing, what I mean is once we are designing, once the designing of the form is finished, we should find 5 to 10 people minimum from the target group to pre-test it. So in pre-testing, you don't need hundreds of people. You simply need minimum of 5 to 10 people whom you go to, whom you administer the form, and whom you ask the questions required, and then you refine the questions based on the responses you get. Now, if we can't get to the people from the exact target group, let's say our exact target group is slightly not reachable in many regards. So what we do is we should find people who are as close to it as possible, as close to the target group as possible in terms of demography. Okay. Now, we should try to get a range of different people who are representative of a target group. And that's what sample means. When you talk about sample, a sample is nothing but a fair representative, a very good representative of the target population, right? Generally accepted definition of sample is that. Uh, we should try to get a range of different people who are representative of the target group. Now, for example, if the target group is young people, that is, let's say, people from the age 15 to 25, what we should do is we should try to include someone who is close to 15, someone who is in the mid, and someone who is close to 25. That way, what will happen is we'll include. Can you please mute yourselves, whoever is speaking? So whenever we
I
talk about a
think
target,
Dr. Mechand, you block all the mics except Dr. Kandarp.
yeah, hello. So I hope I'm audible.
Yes, sir, you are audible.
Yeah, okay. Thank you so much for muting the others. So now, if we take an example, if our target group is young people who are between the age group of 15 to 25, what we should do is we should try to include some who are younger, some who are older, some males, some females with different socioeconomic backgrounds, because what that will do is that will give you a fair representation in terms of the target population. Now, even with such a small number of people, which is just we talked about 5 to 10 people in the pre-testing phase, even with such a small number, chances are high that we will be able to identify most of the major issues with the form. Okay. Now, when we talk about issues, what are some of the major issues whenever we come across a form? So I'm pretty sure that most of you would have filled out forms in your life regarding anything. Okay. So now there are three, four common issues which are identified by many of us while filling the forms in the pre-testing phase. So some people might not understand the question. So whenever I look at the form, I see a question. These things might come to my mind. I don't understand the question. So the language is not legible. Why is this question so long? Some questions might be long. And what long questions do is they make you lose interest. Okay. The participant then loses interest in answering it because it is such a long question. Nobody wants to read a lot of words. Then there might be some questions which might be uncomfortable. It can be uncomfortable to you personally or professionally, or it can be offensive culturally or on a religion basis. So any question which is uncomfortable will definitely elicit no response. So that is very important. Now sometimes what happens is you like the question, you understand the question, but the option you are looking for is not available. So all these are some very common issues which are identified by the participants while the pre-testing phase is on. And these are the issues which you would like to address when you actually administer the questionnaire. Now, once all the testers are done testing the form, it is normally clear what the major problems are. So we can improve the survey to address these problems. So once we are done with the pre-testing phase, we have a fair idea of what refinements are needed, what modifications are needed. And based on that, we can improve the survey to address these problems. However, if major changes are needed to the questions, let's say even after the pre-testing phase, there is still a need of a major upgrade or a major change in the question itself or the structure of the form itself, then it might be necessary to repeat the pre-testing exercise with different people before starting the survey. Or what you will have to do is you will simply have to make a new questionnaire if that doesn't work out. Okay. Next, we move to a slightly larger thing, which is called as pilot studies. So the pre-testing involved only 15, 5 to 10 people. Pilot studies involve a slightly larger sample. And what happens is in pre-testing, we were only concerned with testing out the questionnaire. In pilot study, what we do is we actually do the whole research at a smaller scale. Somebody is saying that there is no audio. Am I audible?
Yes, sir, you are audible.
Okay. So now when we talk about pilot studies, so for complex studies, it is a good idea. So whenever you are doing a study on a large magnitude or a large scale, it is always a good idea to do that in a pilot environment first. So it is a good idea to do a pilot study before starting the actual data collection. Now to do a pilot, we need to test all the survey steps from start to finish. So exactly what I said before, a pilot study is nothing but a micro version of the actual study which you are doing. Why I'm saying micro is because the sample size is way smaller than the intended or actual sample size. The size of the pilot sample depends on how big your actual sample is and how many data collectors you have. So let's say for a typical survey, a sample of around 30 to 50 people is usually enough to identify any major issues with a study. Okay. Now, what pilot studies will do is piloting will usually identify problems with the implementation of the survey. So, if you want to find out the problems in the questionnaire itself, pre-testing is sufficient. But if you want to identify problems with the implementation of the whole survey, then piloting is helpful. Now, examples of these problems include lack of staff training. So let's say a questionnaire is very nice, but the staff is not trained on how to administer it. That is an implementation issue, not the questionnaire issue. So for that, to resolve that, you need a pilot study. Or if there are any challenges with the logistics of distributing and collecting the survey, or if there are any errors in the data entry. So to resolve these issues, pilot studies are needed. Pre-testing won't work, only pilot studies will work. These issues can then be fixed before we do the actual survey. Now, next we move to data editing and verification. So presuming you have already obtained the data, you have done the pre-testing, you have done the piloting if it is a complex study, and then you have actually administered the questionnaire to the intended target sample. And after that, you have obtained data. So what do you do with the data? Do you straight away go into analysis? The answer is no. First, you edit the data, you clean the data. It is also called as data cleaning, right? Data editing. And you verify the data. So once the data collection process is complete, it becomes important to check for possible errors, possible inaccuracies, possible omissions, and other factors. This process of checking and adjusting the responses in the completed questionnaires for omissions, for legibility and consistency, and reading them for coding and storage is called as data editing. So checking whatever data you have obtained for any errors, for something which is missing, for something which is legible or not. Legible means understandable or not. So sometimes in a qualitative study, you might have someone's handwriting which is not legible at all. So to check for that, to check for consistency, and finally reading them for coding and storage is called as data editing. What data editing does is it corrects these errors when possible and makes sure that the minimum data quality standards are achieved. It's very, very important. What data editing does is it corrects the errors which you have detected when possible and makes sure that the minimum data quality standards, it is very important to have quality data. So minimum data quality standards are achieved. It is the responsibility of data editing. Now, there are two types of data editing. The first one is field editing. It is sort of a preliminary editing by the field supervisor. So whoever is into the field, whoever is doing, collecting the data and administering the questionnaire in real time. So this is a preliminary editing by that person in real time as the interview to catch technical omissions, check the legibility of handwriting, as I have stated before, and clarify responses that are logically or conceptually inconsistent. So someone, let's say, has given a conceptually wrong answer or logically inconsistent answer. It is, it can be edited using field editing, or it can be edited by the field supervisor himself or herself. The other type is in-house or central editing. This type of editing is a bit more complex, bit more rigorous than field editing, and is usually performed by a central office staff. So whatever data is collected is usually sent to the headquarters, or usually sent to the office who is conducting the study, and then that office does the central or in-house editing, and it is often done more rigorously than field editing. So it is a better mode of editing as compared to field editing. Now, what are the purposes of data editing? We have stated them before, but we'll state them again so that it becomes clear. The first purpose is to ensure accuracy of the data collected. So it's very important to collect accurate data, and that can only be possible when you do a good bit of data editing. For consistency between responses, for uniformity, for completeness in responses, it's very important. So what happens is, it happens in many surveys, people simply don't fill a particular answer to a particular question. This sort of thing is phenomena is called as item non-response. So to reduce the effects of item non-response, data editing is needed. And how it is done is, it is filled by certain statistical techniques. The data is then filled by certain statistical techniques. Okay. To better utilize the questions which are answered out of order, it's very, very important. Some questions are answered out of order. So how we can better utilize them, that is the purpose of data editing. Now, editing for completeness of data. So let's say some data is missing. How do we complete it? So the first thing, as I've already talked about, the item non-response. How do you deal with it? This is a technical term used for an unanswered question on an otherwise complete questionnaire resulting in missing data. So some person who was a participant in your study has filled out the whole questionnaire but has missed one particular question. That non-response is the item non-response. Now, how is it filled? It is filled either by a plug value or by imputing. What is plug value? An answer that an editor puts. So what will the editor do is, now the editor will put in an answer to replace the blanks or missing values so that data analysis can be performed. The choice of value is based on a predetermined decision rule. Okay, so if a person has answered the questions in a particular fashion, then the decision rule will favor what sort of answer will be filled in the missing data. Okay, so the overall, whenever you do a study, you make certain set of decision rules. So if this is done, this will be the answer. This is how decision rules work. So if one criteria is fulfilled, the answer will be this. If it is not fulfilled, the answer will be something else. So this sort of filling in by the editor of a missing answer to replace a blank is called as plug value. Imputing, on the other hand, is filling of a missing data point through the use of a statistical algorithm that provides a best guess for the missing response based on the available information. So whatever information that has been filled, what happens is a statistical algorithm is run which provides a best guess, a best choice from the choices of answers to fill in the missing data point. I can see that somebody has put in the chat section that the presentation is not displayed. So I would just like to ask it very quickly. Is the presentation visible to everyone?
Yes, sir, it is visible.
Okay. So probably some of the participants have a network issue on their side leading to this. Anyways, next we move to data verification. Now, the data verification is the process of checking the data for accuracy after the data has been obtained. So once we have obtained the data, to check that particular data for accuracy is called as data verification. Now, there are two types of verification. Full verification. So all of the obtained data is checked over here, and the other type is sampling verification. So what happens is, let's say whenever you have a study which involves thousands of participants, you cannot do a full verification because it is time consuming. So what you do is you simply do a sampling verification, just like you do a study on a sample size. In verification also, you select a sample from that particular sample size, and then you check that small sample for any inaccuracies. What verification does is it performs a check of the current data to ensure that the data is accurate, the data is consistent, and the data reflects the purpose it intends to fulfill. Okay. Next, we come to data handling. Again, very, very important. The data handling is the process of collecting, organizing, and presenting the data in such a way that it is helpful to analyze and make inferences about it. There are largely 6 steps in data handling. The first is identification of the problem. The second is collection of the data. The third is presentation of the data. The fourth is graphical representation of the data. So presentation of data and graphical representation are slightly different, which will come to at a later stage, which we'll see at a later stage. The next step is analysis of the data. And finally, the sixth step is that we reach the conclusion. So conclusion. Now, we'll slightly talk about these 6 steps. So the first step is identification of the problem. Now, in the data handling process, the purpose of the problem statement has to be identified and well defined. It is very, very important. Whatever problem or whatever issue you are doing the research on, that problem statement, that purpose or objective of your study is identified and well defined. So that is your first step. The second step is collection of data. Now, since you have already established the purpose of your study or the problem statement, the next step becomes to collect the relevant data. So now the data relevant to the problem statement is collected. The third step is presentation of data. Now, once you have got the data, you need to present it in such a manner which is meaningful and easily understandable. Very, very important. Now, what you do is you collect, you have nice data available with you, but you present it in a very technical form. What that will do is that will confuse the stakeholders. And if the stakeholders are confused, you will probably not reach the objectives which you had begun with, or the purpose of your study might not be fulfilled. So it is very, very important to present the data in a meaningful and easily understandable manner, so that it is it is legible to everyone who is involved as a stakeholder in that particular research. How do you do this? This is done by arranging the collect data in the form of tally marks or table forms, or so you make tables, you make tally marks, and on the basis of that you present your data so that it's easily understandable by anyone and everyone. The next step is graphical representation of data. Now, visual or graphical representation of the data makes the analysis and understanding easier. The presented data can be plotted on graphs. It can be plotted on charts such as bar graphs, pie charts, and so on. So, presenting the data, graphically presenting the data visually in the terms of graphs like bar charts, pie charts, scatter plot, all these different sort of graphs which are available. That is also very, very important, and that helps us in understanding. So you might have come across on while surfing on the internet, or while reading the newspapers, you must have seen certain graphs displayed in the newspaper, or whatever your media is, the accessible media is. You always see graphs or charts which helps us immediately in understanding what is going on. So graphical representation of data is very, very important. The next step is analysis of data. So once you have obtained the data, you have presented it, you have graphically represented it, then the data must undergo data analysis. so that the necessary information from it can be concluded, which helps us in taking further actions. So then you move to the analysis part, where you analyze whatever data you have obtained so that we can take further actions. And these further actions are derived, or these further solutions are derived by the conclusion, which is the last step. So once you are done with the analysis of data, you finally conclude. Okay. Now we'll just very quickly have a look at graphical and diagrammatic representation of data. So why do we use diagrams? Now what happens is the raw data available to us when we collect data is difficult to understand. It's very, very difficult to understand. Diagrams along with tables helps us in understanding the pattern of the data and the shape of the data. So in a way, it basically visualizes data for us. We are able to understand how the data looks like on a paper, right? Tabulation, yes, it gives us the overall picture. When we make tables, it gives us the overall picture. But when we make diagrams, it tells us the pattern, it tells us the shape. And what that does is, when we look at a diagram, like a bar graph, they leave a meaningful impression in mind. They get across our point very quickly. Whatever point we are trying to make, they get across that point very quickly. Now, there is only one downside of the diagrams, that they sacrifice inner details and the accuracy of the data. Now, on the basis of the type of data or the type of variable, there are diagrams which are drawn. So if our variable is qualitative in nature, that is, it has something to do with categories like religion, gender, place of residence. So, whether the house is in the urban area, or it is in the rural area, or it is in semi-urban area. So all these categories, if the type of variable is categorical in nature, we usually draw a bar diagram or a pie chart. On the other hand, when the data is quantitative in nature, we usually draw line diagrams or histograms, right? These are certain types of diagrams which we usually use when we are trying to graphically represent data. So on your screen, you can see a bar diagram, you can see a pie diagram, you can see a scatter plot, you can see a line diagram, you can see a histogram, and finally you can see a box plot. So all these types of diagrams you usually use to graphically represent the data which you have obtained. Now, next we talk about the sample size. Now, there is always, while doing research, there is always a question in our mind: how many people should we study? To do that, we calculate the sample size. So the sample size is defined as the number of observations used for determining the estimations of a given population. Right? So whenever we want to study a particular parameter in a given population, we do a research which involves a certain intended target population. Since that population is very high, we take a good representative of that population, and that representative is sample, and the number of sampling units which we take is called as the sample size. Now, for a given observed sample mean and sample standard deviation, the larger the sample size, the larger the test statistic value is. So many times you must have heard, whenever doing a research, keep an adequate sample size, a large enough sample size, right? So that you can do the study with fair bit of accuracy. So why is that so? Because as the sample size increases, the value of the test statistic also increases, which indicates that there is less margin of error. We can also say that the larger sample size leads to higher statistical power of the test. Now we will talk about power of the test, and types of errors at the end of the presentation. We can say that a large sample size leads to less chances of errors, which are both type 1 and type 2 errors in nature. Now, how do we determine the sample size? Once again a very, very important question. While doing a research, what should be the appropriate sample size? So let's say you are doing a population-based survey, right? You are serving a topic of your choice. So let's say in my case, let's talk about malnutrition, okay, which is a very, very rampant problem in many countries. So the appropriate sample size for a population-based survey is determined largely by three factors. The first factor is the estimated prevalence of the variable of interest. Very important. So whatever our variable of interest is, the prevalence of that. So in this case, we'll take malnutrition as an example. The second factor is the desired level of confidence. How much confidence we have in our own research. So that confidence level. Next, the acceptable margin of error. That's also very important. So whenever we set out to do a research, we always have, a certain confidence in the back of our mind. And we always take an acceptable margin of error depending on the topic we have, depending on the sample size we have, depending on the intended target population. We always keep a certain margin of error, acceptable margin of error in mind. In most cases, this desired level of confidence is 95%. And in most cases, the acceptable margin of error is 5%, right? And we all know when we talk about percent, we can also convert them to decimals. Okay, so 5% can also be called as 0.05. Okay. Now, for a survey design based on a simple random sample, the sample size required can be calculated according to the following formula. So this is a formula which you usually use when you are doing a random sampling. This is the formula which you usually use. N equals to T square into P in parenthesis 1 minus P divided by M square, where N is your required sample size. N is the sample size which you are after. T is the confidence level at 95%, which usually turns out to the standard value of 1.96. Okay. P is your estimated prevalence of malnutrition in the project area. Since we are taking malnutrition as an example in this scenario, the prevalence of malnutrition in whatever the project area is. In your case, it can be the prevalence of the issue which you are looking at. So let's say somebody in this group wants to do a study on hypertension, or somebody in this group wants to do a study on diabetes. So that the prevalence of diabetes or the prevalence of hypertension can also be included. It simply replaces the malnutrition in this particular equation. So prevalence of issue at hand in the project area. M is your margin of error, usually taken as 5%. So the standard value is 0.05. Now what happens is, let's assume that in district X, it has been estimated that roughly 30% or 0.3 of the children in the project area suffer from chronic malnutrition. So over a long term, over a long period of time, people have suffered from malnutrition, and this prevalence comes out to be roughly 30%. Now this figure, let's say, has been taken from national statistics. So whatever country you belong to, there is always a national statistics program or a commission which takes these numbers and then sends it to the World Health Organization, or in many cases the WHO also helps in doing this. So let's say that figure comes out roughly as 30%. Okay. Using the formula which we have already talked about, we calculate the sample size. So you put in all the values in this sample size. 1.96 we have already talked about. In most cases, the confidence level at 95% is usually the standard value of 1.96. You put all these things in the formula. Prevalence is 0.3. Then in brackets or in parentheses, you have 1 minus 0.3, which is the other side of 0.7. And in the denominator, you have 0.05 whole square. So when you calculate all this, you get down to the value of 323. Okay. So in many cases, and this 323 can be anything, it depends solely on the prevalence of your issue at hand. So let's say if the prevalence is 40%, so this 0.3 now becomes 0.4. So the value of n changes, right? So it all depends on these basic three factors which we have talked about previously: the estimated prevalence of the variable of interest, the desired level of confidence, and the acceptable margin of error. All these three factors are changeable. Let's say the level of confidence is slightly less, you take it as 90%, it changes to the Z score, or the Z score in the log table which is given. So what happens is, you don't have to get into all this. This is just the formula. Now you have many statistical softwares available which will do this thing for you. This is just for educational purposes. You don't have to sit down, and write this on a piece of paper and do all this, because the software will do it for you. We are just having this discussion for educational purposes. Okay. Now, whenever we calculate the sample size, let's say in this case, we have obtained 323. Now we add 5% to it. Why do we add 5%? Because it is contingency. So to prevent loss to follow or any other last minute changes or contingency, a margin of 5% is taken and added to the calculated sample size. So we have 323 plus 5% of 323, which comes out to 17. So the effective sample size now becomes 340. Understood? We have the calculated sample size, which is 323. What we did was, we just added 5% to it to prevent any loss to follow up or any other contingency. I'm seeing a lot of messages where people are saying that it is not audible, or the presentation is not visible. Dr. Meher?
Sir, all the things are fine.
Okay, okay.
Audible, and presentation is also visible. No
Okay,
problem
sir.
at all.
Okay, sir. So just wanted to clarify that bit. Anyways, so after adding the contingency 5% or the margin of 5%, now our sample size effectively becomes 340. Next, we have something which is called as the design effect. So what happens is, this 340 was obtained when we did a simple random sampling. Now we all, most of you are aware of the sampling methods. Okay, the different types of sampling, which is the probability sampling and the non-probability sampling, right? So whenever we talk about simple random sampling, we use the previous formula. But let's say when we have to attend to a very, very large population, covering cities as a whole or states as a provinces as a whole, what do we do in that case? We use the design effect. So for surveys like our example, what we do is, we change the method of sampling. If we are using cluster sampling or non-probability sampling or stratified sampling, then what we do is, we want a larger sample size. And since 340 is a very comparatively smaller sample size, we either double it or triple it based on what population we are looking at. This particular phenomena is called as the design effect. If you are using a method of sampling which is different than that of simple random sampling, you increase the sample size. And why do you increase the sample size? Because you want to get more accurate data, and the chances of the errors will be less. So this phenomena is called as design effect. In our scenario, so for surveys like one which we have mentioned, like malnutrition, it can be any other issue also, right? The type of sampling for a larger intended population we usually use is cluster sampling. So the design effect is usually taken as 2. So what we do is, we simply double the calculated sample size. So the formula is INI, which is effective sample size, N is the existing sample size, and D is your design effect, which is 2 in this case. So therefore now our sample size becomes 340 into 2, which is 680. So now instead of only having 340 people as the study participants or as your sample size, now you have 680 people, just the double of that. And why we have done so? Simply to preserve or to maintain accuracy, because we are using a sampling method which is slightly less stringent as compared to simple random sampling. So just to adjust for that, we use the design effect. Okay. Next, we move to drawing inferences from a study. Now we have done everything. We have collected the data. We have analyze the data. We have done everything possible with the data, which we could have done. Now the time comes to draw inferences from the study. What do we understand by the study? So the inferences from a study can be drawn through hypothesis testings. Now, hypothesis, what is a hypothesis? Hypothesis is a supposition made from observation. So it is a theory which you have made based on existing information or existing facts. On the basis of hypothesis, we collect the data. Okay. The hypothesis is nothing but a tentative justification, the validity of which remains to be tested. So let's say I do a study, or any one of you does a study, and you make a particular claim. So will anyone believe that claim right away? No. Why? Because its validity is still needed to be tested, is still needed to be checked. How do we check it? That is a different thing. We check it by hypothesis testing. But when we talk about hypothesis, it is nothing but a tentative justification. It is not the whole justification or the exact justification. It is a temporary or a tentative justification for a phenomena, the validity of which still remains to be tested. Now, as we all know from our previous classes also, and I'm sure you must have heard of this, there are two types of hypothesis. The null hypothesis, which is often abbreviated or labeled as HO, and the alternative hypothesis, which is usually labeled as HA. Okay, these two types of hypothesis we keep in mind whenever we are doing any research. Now, if the hypothesis HO is true after analysis, our test accepts it because the results fall within the zone of acceptance. So whenever you plot your data on a graph, in many cases, what we have seen is we obtain a normal distribution, which looks like this. We also call it, as a bell-shaped curve, right? Since it is in the shape of a bell, right? We also call it as a bell-shaped curve. So if on the either side, we are approximately 2 standard deviations away, both on the positive as well as the negative side, we say that if our results fall within this, we accept the null hypothesis. So this zone is called as the zone of acceptance. If our results fall outside this, we say that the null hypothesis is rejected, and those particular zones are called as zones of rejection. Okay, so what happens is, if HO is true, our test accepts it because the results fall within the zone of acceptance. I'm just repeating myself so that it's more clear. If the hypothesis HO is false, our test rejects it because the estimate falls in the zone of rejection. Now, it is here where we can commit certain errors. And how? So when a null hypothesis is tested, whenever we are trying to test our claim, or whenever we are trying to test our hypothesis, there may be 4 possible outcomes. The first outcome can be the null hypothesis is true, but our test rejects it. The second outcome can be the null hypothesis is false, but our test accepts it. The third outcome is the null hypothesis is true and our test accepts it. And the fourth outcome is the null hypothesis is false, but our test rejects it. So all these 4 scenarios are possible whenever we are testing a hypothesis. If our null hypothesis is true, even then the test rejects it, we are committing type 1 error. Right? So type 1 error is whenever the null hypothesis is true and we still reject it, we are committing type 1 error. It is also called as alpha error. And talking about type 2 error, whenever we are accepting the null hypothesis, when the null hypothesis is false, we are committing type 2 error, and it is also called as beta error. Okay. Now, next phenomena is something which is called as p-value. Or p-value is also called as probability value. Right. So just to say out the full form of p in this, p-value is probability value. Now, very simply put, the probability of committing type 1 error is called as the p-value. The probability of committing type 1 error. So what was type 1 error? Accepting the null hypothesis, rejecting the null hypothesis when it was actually true. So when you do that, you are committing type 1 error, and the magnitude of doing that, or the probability of doing that in percentage, is called as p-value. Thus, the p-value is the chance that the presence of difference is established when actually there is none. So when there is no difference, but you detect a difference, you are making an error, right? When there is actually no difference, but you establish that yes, there is a difference, you are making an error. The chance of committing that error, which is also called as type 1 or alpha error in other words, is called as the p-value. If the p-value is less than 0.05, so can anyone from the audience convert 0.05 into percent? If I say that the p-value is 0.05, what is it in percentage? If you're not able to speak, just put it in the chat section. 5%, yes. So I assume all of you know that it is 5%, and I'm getting answers also. So if the p-value is less than 5%, we accept the null hypothesis. Why? Because we assume that there are no errors. So this 5% is usually the margin of error, which we talked about while we were talking about sample size. So that margin of error is usually the similar as p-value. So if our p-value is less than 5% or less than 0.05, we accept the null hypothesis. But if our p-value is more than 0.05, we reject the null hypothesis. Why? Simply because the margin of error has been exceeded. There is more than 5% error in our results. And that cannot be a coincidence. That cannot be simply due to chance. There is a reason behind it. If our margin of error is exceeded, we say that there is some other factor which is affecting the results. Therefore, we should not merely rely on the results alone. We should either repeat it or we should test it in some other environment or with some higher sample size. So I hope you understood what the concept of p-value looks like. I'll reiterate it again. If the p-value is less than 0.05, we accept the null hypothesis. If the p-value is more than 0.05, we reject the null hypothesis. Okay. Next, we talk about the power of the test. So the statistical power of a test is the probability that a study or a trial will be able to detect a specified difference. So the power of the test, in other words, is the probability of not committing the type 2 error. Right? So type 2 error was accepting the null hypothesis even when it is false. That was type 2 error or beta error. Right? The probability of not doing or not committing the type 2 error is the power of your test. Or in other words, it is 1 minus beta, the value of beta. Okay. This is calculated as 1 minus the probability of type 2 error. That is the probability of correctly concluding that a difference exists when it is indeed present. So if there is a difference present and you conclude that yes, there is a difference present, then you say that the power of the test is high. Understood? If the test is correctly identifying or correctly concluding that yes, there is a difference, then we say that that statistical test has a high power. Now we talk about the concepts of precision and validity of measurements. What is precision? The degree of resemblance among study results if the study was to be repeated under similar circumstances. So if you repeat your study in similar circumstances for for a lot of times, if there is a resemblance between the study results or the study results are similar in all those events, we say that your measurement has precision, right? So obtaining similar results after doing the test again and again, that means that that test has a higher precision rate, right? Lack of precision is called as random error. And this can be due to anything. Okay. So if there is a lack of precision, if you're not getting similar results, it might be due to random error. Next, we talk about validity. So what is validity? Can anyone tell me in the chat section, what do you think what validity is? I'll await your answers. Meanwhile, I'll move and I'll move to say that validity is nothing but the authenticity of a claim. Right? How authentic is your claim? How valid it is? Right? So validity is the extent to which a test measures what it claims to measure. So let's say I design an instrument which is to be used for measuring the blood sugar of a particular person, of people, right? I design an instrument, a blood glucometer. How do I know whether it is valid or not? If my test measures what it claims to measure, so I'm claiming that this device is certain percent effective. If it turns out to be that, I'll say that yes, my device is valid or my test is valid. It applies to statistical tests also, right? So it is vital for a measurement to be valid in order for the results to be accurately applied and interpreted. If your measurement is not valid, then your results cannot be accurately applied, cannot be accurately interpreted. So for example, if you come across a simple claim that drinking alcohol causes liver cancer, what is the validity of such a claim? It remains to be tested. Okay, it can only be claimed to be valid. It can only be claimed to be valid, or it can only turn out to be valid if it is proven with a study. Without proving anything, we cannot simply accept any claim, right? So we simply ask the first question which comes to our mind whenever we see a statistic: what is the source? And then and only then we establish whether the measurement is valid or not. You might have come across many statistics in the newspaper. All of them, almost all of them, give source that this data was obtained from certain source, right? Without the source, that is just a plain statement, a plain sentence. It has no meaning. With the source, it has a lot of meaning because it gets validity, it gets authenticity. Understood? Now there are two types of validity: the internal validity and external validity. When we talk about internal validity, it is the extent to which a study is free from flaws, and that I'm sorry, and that any difference in a measurement is simply due to an independent variable and nothing else. So the more your study is free from errors, is free from bias, is free from flaws, the higher the internal validity becomes. This is a within the study scenario. Okay. So within the study, if there is less bias, we say that it has good internal validity. On the other hand, if your study can be externalized, can be generalized to a wider population. So whenever you do a research, you have an intended target population, right? Your study might be very, very valid internally in that particular target population. What if I ask you that can you do the same study on a different group in a different country? In other words, what I'm trying to ask is your study externally valid, or is your claim externally valid? If I do the same research in some other country on some other intended target population, and I find that my claim is true, even there also, then I say that my study has good external validity. Okay, so external validity is nothing but it indicates the generalizability of the study. How you can generalize the study, right, from a representative study sample on a wider target population. This generalization can then be applied to different situations, different groups of people, different settings, and different conditions, etc. You can see this, very nice image, very simple and very nice image. Internal validity is truth inside the study, right? Internal validity is truth inside the study. Now, when you move from truth inside the study to truth in real life, or you generalize it, then you say that your study has both good internal validity as well as good external validity. Okay, so this is what internal and external validity are all about. The source of this image is given in the PPT. You can access it. These are my references, and thank you for being patient. Thank you for listening to me, and being so nice. Thank you so much. With this, I move to
Sir, there are
Dr.
some
Ashish
few
Manocha.
questions in the chat box. Please
Sure, sir.
reply there.
Sure, sir. I'll meanwhile you proceed with the talk. I'll reply them in the chat section also. So somebody say, why do we test the null hypothesis? So we proceed on the basis of the null hypothesis. I hope I'm audible to the person who addressed this question. I cannot exactly pronounce the name. EWUNU. So Evinu Birhan, I don't know whether this is your name. Please, accept my apology if I'm not able to correctly pronounce it. But why do we test the null hypothesis? See, we always proceed on the basis of null hypothesis. Okay, alternative hypothesis we keep at the back of our mind, but we always test the null hypothesis. Okay, because that is the first claim which we are making. That is the actual claim which we are making. We want to test that, and only by disproving or proving it, we'll define or interpret our results. Any other question? So most of the so what is the role of effect size on sample size calculation? I think I've already explained it in my presentation on the basis of the type of sampling method which we are using. So I'll just give a very short intro of sampling. So sampling is the process by which you actually select your sample size. Very simply put, right? The process of selecting a sample from a target population is sampling. Now sampling is of two types: probability sampling and non-probability sampling. So probability sampling, in other words, is also called as random sampling. So now there are four methods of probability sampling which are used, or random sampling which are used commonly. So first one is your simple random sampling, where there are 50 or 100 odd people and you simply pick out people randomly. So the third one, the fifth one, the ninth one. So there is complete randomness in selecting it. That sort of sampling is simple random sampling. And for that, the value of 340, which our example obtained in the presentation, that is sufficient because we are simply using a simple random sampling. Now, the other type is stratified random sampling, where we stratify the target population on the basis of certain characteristics. The other type is cluster random sampling, where since there is a very, very large population involved, we simply pick clusters of people from that particular intended target population. So whenever you are picking clusters from a very large population, what might happen is you might have way too much homogeneity in a particular cluster. So just to avoid that, just to maintain the fairness or maintain the good representativeness of the sample size, you increase the number of people in the sample size, and that is called as design effect. So the effect of design effect on the sample size calculations solely depends on the type of sampling method which is used. Okay. Any other questions? Okay, so most of the chat section is filled with network issues, and which is in this COVID era we are all facing network issues because most of our work goes online. So I think that's all as far as the questions are concerned. So okay, so what is the rule to use design effect of 1.5? See, I don't know whether how you pronounce it. It's Niquis. So I'll just go with Niquis. So your question has been, what is the rule to use design effect of 1.5 or 2 or 2.5? Because I have seen some use for 1.5 or 2. That solely depends. Again, I'll repeat, that solely depends on the type of. That solely depends on the. Dr. Mehak, can you please mute yourselves if possible? Thank you, sir. So the design effect Depends on the type of study which you are doing. It is as per your convenience. If you are not dealing with a bigger sample size, you can use it. You can use 1.5. If the sample size is very large, you are doing a national level survey, you can introduce the design effect in such a manner. All I'm saying is everything depends on the type of population and the sampling method which you are referring to, right? So what if the incidence or prevalence of the condition is not known? Then how to calculate sample size? Okay, it's a good question. So you assume it based on previous studies. Whenever you don't know the recent statistics of a particular issue at hand, you assume it on the basis of your literature review. And that is how you come, that is why you do literature review. So whenever you're doing research, you do research, you do your literature review. And the whole point of doing that is acquiring more information so that you can design your research question accordingly. You can design your objectives accordingly, and then you can select your sampling design or the study design in that particular manner. So if incidence or prevalence is not known, we only talk about prevalence usually. So if prevalence is not known, we refer to the previous literature. So okay, so how to calculate design effect? So I've already explained it. We refer to the sampling method which is used. If we are using cluster or stratified sampling, we usually take it as 2. But then again, it can depend on the size of the population which you are referring to also. Ashiji, can you please take over for 2 minutes? I have to drink water because I've been speaking for
Please,
pretty good
please.
enough time. Thank you so much.
So I think it was a wonderful lecture and everyone got it. And we will be sharing this presentation with every participant if you want. And you can ask to Dr. Mehachan, or you can ask to, the moderator, that is me, if you want this presentation. Just
I would just like to point out, I'm putting my email ID in the chat section. You
yes.
can send your questions to that particular email ID also, because time is of essence, and we have a time constraint here. I cannot take all the questions. So I would simply put in my email ID for everyone to see, and you can send in your questions as and when you please, and I'll be more than happy to answer them.
Dear participant, you can find the email address in chat box. And also, if you have more question, you can unmute right now and ask from speaker Kander Mathur. You have the permission to unmute yourself.
Okay, shall I ask?
Please go ahead. Please go ahead. Please go ahead.
Okay, thank you. How we calculate if the p-value of existing p-value is very small or too small? How we calculate sample size?
So
as you
actually,
told me, you have told us you can use the existing literature. That was your answer. If the existing literature have too small p-value, how we calculate sample size?
So the p-value actually is obtained after your results are obtained. Okay, so you cannot presume your things simply by p-values. P-value is something which you obtain after you have run the analysis of the data. Okay, so we don't go by the p-value of the literature, and we simply estimate the prevalence. So we never go word for word when we doing the literature review. The literature review is simply for a reference, right? It's not a very concrete evidence. And that is why research is done. In science, nothing is concrete. We are always trying to find something new from whatever exists. If we were to refer word to what exactly was said in previous research, there is no need for new research, right? So if even if the p-value is too low in the previous research, you still go ahead with your own data. you obtain your p-value and you simply say that this is my p-value. But your p-value is always obtained after you have done your analysis of data. Okay, so if your p-value is more than 5%, you say that, okay, my null hypothesis is rejected. If your p-value is less than 5%, you say that my null hypothesis is accepted. The p-value of previous studies have no effect on your research. Okay.
Hello, Dr. Kandar. I have a question.
Sir.
I need to ask how to calculate sample size if you want to do a normative study. For example, we are interested in knowing the blood pressure values, and we need to follow up the same for a period of years. Okay. So
Okay.
if we are interested in knowing in doing the normative study, how to calculate the sample size in such case?
So, if I'm not wrong, what you are explaining is sort of a cohort study, right? Because you're
Yeah,
dealing with a
exactly.
NCD,
Yes.
right? A hypertension, or you're talking about that. So, in a cohort study, that again depends on the population density. There are many demographic factors actually responsible for that, right? How the population pyramid looks like, what is the percentage of the older population which is more susceptible, to that particular NCD. So you look at the existing statistics, which is already there available. You look at the recent census. From that, you get your population pyramid. You again refer to the literature review, previous literature reviews done previously, in other countries which are closely, or in other areas which are closely, related as far as population and demographics is concerned. And then on the basis of that, you go ahead with that particular decision. So all that is, all that depends on previous references also. But once again, I want to reiterate, previous references are not, very concrete. So we should always try to find more and more, data. And that is why in my example also, I specifically, when I talked about malnutrition, I specifically stated that this prevalence is obtained from national statistics, because that is usually the most trusted, statistic whenever we try to do research on health related issues.
Okay.
I hope this answers your question, sir.
Yeah. Thanks.
Sir,
Yes, any more
Well,
question, please?
yeah, okay.
question regarding the
Your question actually is not clearly audible. What I would request is, if
design. So, sir, how?
hello, it wasn't legible, sir. It wasn't very clear. Can you please ask it again, or if your network is not up to that mark, can you please ask it in the uh, chat section, if possible, sir? I
Sir,
only
I
got
wanted
that
to know
design effect and simple.
how to calculate
Not
the design.
how to calculate the design effect when? Hello. I would insist to you to put your question in the chat section, because that would be way better. Meanwhile, what I'll do is I'll look at some other questions. So Dr. Sigan Isaac Ovediji, I hope I'm pronouncing it right, has asked a question. In a situation where a student is unable to get funding and unable to meet up with the sample size, what are the options available? Very simply put, change your study design or change your topic in very simple words, if I say this. Or what you can do is, you can ask for funding. If you have, donors available nearby, you can always ask for funding. If not that, please select a topic which is suitable for a student to do. Because see, if so, yeah, it's fun. Nice question, actually. Yes. So what happens is, whenever you do research, you always do research based on your own capacity, right? You don't, you can dream big. There's no, there's no harm in it. Dream big, but you should always have a look at the resources available. If you don't have many people available, if you don't have funding available, try to do a study which is on a very small level, or a small scale study, right? Or change the topic, or you can opt for a qualitative study, right, where you don't have to do much of spending. Yes, some qualitative studies do attract a lot of spending, a lot of funding, but try to select a study design which is more suitable to the current resources which are available to you. I presume Dr. Abhishek Mishra is asking how to calculate design effect when you have the sampling method as simple random sampling. So am I right, Dr. Abhishek? If you can hear me and if you can answer with a simple yes or no. I'm sorry. Oh. So anyways, it seems that we are having some issues in connecting to Dr. Abhishek. I would once again like to reiterate my email ID is there in the chat section. You can always use it to ask questions and I'll try my level best to answer them. Dr. Meher? Dr. Meher, are you there?
Yes, sir. I am here. I am with you.
Yes, sir. So shall we close the session for now? And I can take the questions at a later stage if you permit so.
Yes, sir. It's fine. Dear participant, if you have more questions, you can send it to Dr. Kander Mathur on their email address. Okay, because it's a long session and at some places there are network issues and we are not able to take your questions properly. So I will ask from Professor Ashish to conclude the session and then after we will present the certificate.
Sure, sir.
Thank you, Dr. Mehchan. Thank you, Dr. Kandarp, for such a wonderful session. And it's very important to know for every public health researcher or public health scholar to know about the data collection, which is an important aspect of any type of research study. So you gave a very, you can say, a very insightful lecture, and you make student understand about which data to collect, how to collect the data, who will collect the data, when to collect the data. You have covered all these points. You also mentioned about the hypothesis or research problem, the research design, the information gathered about the variables being studied. You covered each and every aspect very fine, in a very fine manner. And again, I would like to thanks from each and every participant from each and every country from where the students have joined. And I would request students, scholars, to you can post any sort of questions to Dr. Kandarp Mathur's email address, or you can directly talk to Dr. Mehchan, or you can directly contact me. So thank you so much, everyone. It was a very wonderful evening. So over to you, Dr. Mehchan. So it's just a certificate of appreciation to our speaker, today's keynote speaker, Dr. Kandarp Mathur.
Yes, sir. I wish all the luck to all the scholars present here in their academic journey, their journey of research, and I'm pretty sure that all of you will definitely do good wherever you go in life. So thank you so much again, and wish you all the luck in life.
Thank you, Dr. Kandarp. Thank you, everyone. I think we should close this session, and we will meet by tomorrow. Over to you, Dr. Mehchan.
So the session is over and we will join the same meeting tomorrow at the same time. Thank you, everyone.
Thank you so much,
Have
sir.
a nice time.